nearly 3,000 meters, the Zugspitze, Germany's highest mountain, is famous for its breathtaking panorama. And nowhere else in the country is the atmosphere so clear. Here, at the nation's highest environmental research station, scientists are tracing a disturbing trend. They monitor the Earth's atmosphere throughout the year. And they are observing the dramatic rise of a dangerous greenhouse gas that many do not even know about: methane. The man in charge here is physicist Ralf Sussman of the Karlsruhe Institute of Technology. With his observatory, he captures the light of the sun and directs it into the interior of the mountain station. The researchers are worried. What is happening in the Earth's sensitive atmosphere? In the lab, they separate the light into individual wavelengths, which gives them an especially precise insight into the atmosphere's composition.
All right, Marcus. Let's have a look at our current solar measurements.
For a long time, they have been observing a permanent increase in the concentration of carbon dioxide. But in recent years, something strange shows up in their measurements. Each gas cuts typical lines in the solar spectrum, and one of the blue gaps in the spectrum gets deeper and deeper. Ralf Sussman is very concerned. The concentration of the greenhouse gas methane in the atmosphere is rising, up and up.
Methane is a very critical greenhouse gas. On the one hand, it disappears from the atmosphere within 10 years, as opposed to carbon dioxide, which stays in the atmosphere for thousands of years. On the other hand, in those 10 years, it contributes at least 100 times more to global warming than carbon dioxide.
After CO2, methane is the second most important human-made greenhouse gas. It has been the cause of about 1/4 of global warming up to now. But where does the colorless and odorless gas come from? There are natural sources. Wetlands emit methane as organic matter decomposes, and it is also released during forest fires. However, since the dawn of industrialization, humans have greatly increased methane emissions. For instance, factory farming produces large quantities. And gas from a second major human-made source is released into the atmosphere through the extraction and use of fossil fuels. Methane is the main component of natural gas. Humans have more than doubled the methane concentration in the atmosphere so far. And Ralf Sussman's measurements show it's getting worse. What is the source that causes the extremely rapid increase that he has observed over the last 15 years? Measurements of a different gas, ethane, that also increases, provide Ralf Sussman with a vital clue.
Ethane is the second most frequent component of natural gas after methane. But farming, cattle husbandry, produces no ethane at all. The fact that methane and ethane both suddenly started increasing in 2007 tells us that of this entire increase from 2007 to today, at least 40% of this increased atmospheric concentration has been caused by oil and gas extraction.
Studies from around the world confirm it must be more than 80 million metric tons of methane that escape into the atmosphere as natural gas every year. How can that be? We want to find out and go on a worldwide hunt for the methane leaks. In Europe, About 1/3 of the consumed natural gas is used to heat houses, offices, and stores. Our cities are crisscrossed by a subterranean network of gas pipelines that deliver it. Is natural gas escaping from this distribution system unnoticed? Thomas Ruckman from the University of Utrecht in the Netherlands wants to know just that. Results by American colleagues have inspired the climate scientist to search for natural gas leaks in Europe as well. His van is equipped with a measurement system that continuously seeks traces of methane in the intake air. The researchers drive systematically through the streets of their hometown, Utrecht, always on the lookout for unusually high concentrations of methane, the main component of natural gas. Not long, and the device reacts strongly.
Oh yes, nice. There it is. Good.
The methane level in the outside air is suddenly extremely high.
Yeah, go ahead.
Is there a natural gas leak nearby? Now the search must continue on foot. Where exactly is the colorless and odorless methane coming from? The scientists slowly work their way towards the source with their mobile detector. Apparently, the dangerous greenhouse gas is seeping through the cracks between the pavement slabs.
Yep, 5 ppm.
Since they are measuring both ethane and methane, they can immediately differentiate natural gas from other methane sources, such as sewage.
Come to this side again, then we can...
Right at the drain, the concentration is so high that it is almost an explosion hazard.
This is the big one here, right?
Yeah.
There is no doubt. Natural gas is escaping here.
We regularly find a handful of leaks every time we drive out. We'll now inform the gas network operator that there's probably a gas leak here, and they can dig a hole and determine where it is exactly. Of course, we can't see that from the surface. We only see where it's being released into the atmosphere.
Today, Thomas Ruckman finds several leaks all over the city. Luckily, none of them is so big that it poses a danger to residents. Though local gas suppliers monitor the lines themselves, they are still unaware of all these leaks.
Yes. Yeah.
The gas suppliers have varying control frequencies. It depends on what kind of pipeline material they've buried. It's supposed to happen annually, but can sometimes take 3 or 5 years. Which means a leak that forms and isn't detected quickly can be there for months or years before it's actually repaired and the emission is stopped.
But then in other cities it can be...
Together with researchers from other universities, Thomas Ruckman has now searched for methane leaks in 11 European cities. The result? Precious natural gas is escaping from the grid everywhere. This is completely unnecessary. Gas suppliers need only search for leaky spots more frequently and more thoroughly.
By 50%.
Yet, the scientists tell us, municipal gas networks are probably only responsible for a few % of the 80 million metric tons of methane that escape as natural gas. Where does the huge rest come from? In Paris, we visit a company that specializes in global energy and environmental analysis. Kairos is a startup that was established to advise companies and investors in the oil and gas sector. One of the founders, Antoine Alf, was formerly a chief analyst with the International Energy Agency. At Kairos, he provides his customers with high-quality data on the extraction, trade and consumption of oil and gas. Some of his clients began asking whether and where methane, the greenhouse gas, escapes in the process. His team of data analysts began searching, with the help of information anyone could have used. The European environmental satellite, Sentinel-5P, has been orbiting the Earth since October 2017. The instrument on board measures pollutants such as ozone and formaldehyde, as well as methane. It creates a world map of methane concentration once a day. Yet it measures all the methane that has been released over years, from natural sources as well as from human-made ones like agriculture and industry. From this huge amount of public data, the analysts try to single out the methane that is released into the atmosphere with natural gas on a particular day.
Dans le Permian, tu vois, on a des images par trimestre, on peut avoir jusqu'à 60 images par 70.
It entails a huge amount of processing of artificial intelligence modeling. You need to understand methane, you need to understand the oil industry, you need to understand how the weather and wind patterns affect the dispersion of methane. So we combine all these inputs to develop algorithms that process the raw data.
The data specialists in Paris have recently succeeded with something that was previously not possible. They use their computer programs to filter out specific regions where large amounts of methane are released. They find them all over the world, exactly in the regions of major natural gas and crude oil extraction.
Methane is a problem, it's a negative, and for a long time there's been a kind of a defensive attitude towards methane. No, I'm not emitting methane. No, those measurements cannot be right. I'm clean, I'm good. And transparency is still lacking for many producers, including some of the majors.
Is this also true for companies that produce in Germany? We try to gain access to one of the approximately 1,100 well pads in the country. After a rejection from oil multinational Exxon, we negotiate with the largest German oil and gas company, Wintershall-Dea. Finally, we are allowed to visit a plant in the northeast of Germany, near Bremen, where gas is extracted. Do large amounts of methane escape here unnoticed? The company has recently also begun asking itself just this question. Wintershall-Dea has voluntarily committed to look for leaks in its facilities once a year, in Germany for the first time in late 2021. Sensitive gas cameras are used to track down potential leaky spots. Technician Marcel van der Koolwijk demonstrates how the camera works using a gas cylinder. Optical gas detection is based on the fact that gases absorb part of the radiation and thus become visible on infrared images. The gas is not visible using conventional video technology. It only turns up as a black cloud in infrared mode. Now the technicians systematically search the plant for leakages. Hundreds of seals, connections, and pipelines must be checked. In addition to the gas camera, they use a high-precision sniffing meter to look for the tiniest leaks. Wintershall-Dea tells us that a handful of small leaks are typically found during the two-day inspection of such a plant. Their gas camera does not register a leak, though, while we are filming on site. Good for the company, as the management would not have appreciated such images.
In der Tat versuchen die Unternehmen, die Emissionen zu verringern.
The companies are in fact trying to reduce emissions.
Nicht immer direkt alles glauben.
You don't have to completely believe everything they say, though.
Wichtig, unabhängige Messungen.
That's why it's also important to carry out independent measurements and to have the companies really deliver believable data. But ultimately, we still see methane being released, even more last year than we've ever seen before.
Where do the millions of tons of natural gas that are detectable in the atmosphere escape from? Independent measurements indicate that it's not happening in Germany. This is plausible, since less than 0.1% of global crude oil and gas extraction comes from here. In Europe, Norway, Great Britain and the Netherlands are the largest producing countries. Yet added together, all of Europe supplies only around 5% of global production. This suggests that Europe's portion of global methane emissions from oil and gas is rather low. The major sources of oil and gas are elsewhere, in Russia and the other former Soviet states. And in the Middle East, with the major producers on the Persian Gulf. Over the past 15 years, production has particularly increased in North America. By now, around 1/4 of global crude oil and natural gas is produced here. A large portion of it comes from the Permian Basin in the southwestern United States. This region, on the border between the states of Texas and New Mexico, is one of the global centers of the billion-dollar industry. Around 40% of American crude oil is produced here, and natural gas extraction has increased by more than 300% since 2011. There are more than 100,000 boreholes in the Permian Basin. One well pad follows the next. How much natural gas, and with it climate-damaging methane, escapes during extraction? The Colorado State University has its own testing grounds to investigate exactly this question.
So you're thinking over here?
Here we meet Daniel Zimmerli.
Okay.
The engineer has been developing methods to track down methane leaks in the industry for more than 10 years.
I think we'll be good. Yes. So, and one over there.
He supervises a unique testing facility. What looks at first glance like a typical extraction facility for oil and gas is just a deceptively realistic facade. Here, the natural gas doesn't come out of the ground, but is delivered by truck. It is distributed throughout the grounds through hidden pipelines. Its release targeted all over the facility. This allows the researchers to test measurement devices and to train technicians to track down leaks in oil and gas extraction.
Look at this, at the vertical pipe, there's a little valve sticking off horizontally.
Their knowledge about typical weak spots has changed.
Here.
Probably the big thing that's changed in the last 5 years is when we talked about fugitive emissions 5 years ago, people were interested in kind of small things like, this joint or this piece of equipment. And that was where the focus was. And what we've learned in the last 5-6 years is that the big problem is things we weren't even looking at 5 years ago, where you end up with large emitters because some valve failed or some process failed and you have a very large plume.
You're talking about the companies that run those sites.
And the regulators. The companies that run the sites, the regulators that were constructing the programs. I would say even the NGOs that were kind of looking at emissions didn't really quite understand the frequency and the size.
Do these large amounts of gas that are apparently released into the environment unnoticed explain the strong increase of methane in the atmosphere? We meet Iman Hill, the General Secretary of the International Association of Oil and Gas Producers in Houston, to find out.
We're here today to talk about methane, right? I mean, the oil and gas industry is big and it's international, right? So do you represent like all of it?
I can confidently say that we represent our industry, and we have members from every continent. Now, we concern ourselves with looking across our membership and their membership and being as global as possible to give our members the toolkits to be able to, as you know, accurately as possible, define their baselines with respect to what their current methane emissions are, and then encourage them, and again, providing actual hard deliverables in the form of a toolkit to allow them to start to put together methane emissions reduction plans. And fundamentally, nobody in this sector doesn't believe, there's not one single member company that I know of that doesn't believe that this is a top priority for them, and it's top of the agenda for the work that they're doing.
This sounds exemplary. Yet, none of the companies that we contact in the USA allows us to film one of their facilities. We receive one rejection after another.
We respectfully decline participating in the production. Unfortunately, we cannot accommodate your request at this time. At this time, we are not able to accommodate this request.
Can large methane emissions really remain unnoticed? We contact independent researchers. Scientists from the Environmental Defense Fund, or EDF, a non-governmental environmental protection organization. They show us their helicopter, equipped with a special camera that will help them look for methane emissions today. EDF expert David Lyall documents them here in the southwestern USA as systematically as possible. This type of helicopter is also frequently used by the American Environmental Agency. The EDF has rented it for its own research program, financed by foundation grants and donations. Today, the environmentalists are here to get their own impression, and also to take a look at facilities with methane leaks on the ground. The helicopter will check on more than 60 extraction sites today, in a sequence determined by the scientists. On the live image, the crew targets one facility that extracts both gas and oil. The gas camera will be able to recognize methane leaks in infrared images. This facility is an immediate bullseye. A continuous stream of methane is escaping from the emergency valve of one of the tanks. The helicopter crew reports the find to the ground station. Now, the EDF researchers set out. Fortunately, they can drive relatively close to the plant. Many other well pads can only be reached via private roads and are sealed off from the public. this plant is unmanned, like most here. The EDF researchers keep a safe distance from the facility so as not to enter the premises illegally. Even from this distance, their special camera should be able to recognize the escaping gas. What is happening here?
So at this site, we are seeing constant emissions coming from these valves at the top of the tank. So I think what was happening at this site is this equipment over here is the separator, and it separates the oil and gas. And if it's working normally, it will have the oil go to the tanks and the gas go to the pipeline so it can be sold to customers. But what we think's happened is the separator had a stuck valve, so the gas, instead of going to the pipelines, was going to the tank and then outside to the atmosphere. So not only is this causing methane emissions, but the company is losing product. So it's really important for the companies to fix the equipment, in this case the separator. They would stop the emissions and they'd sell more natural gas.
And this find will not be the only one today. Over and over again, the crew discovers leaky tanks. As well as a flare that is not completely burning excess natural gas.
Yeah, it's a very common problem. So the two biggest issues we see are abnormal emissions coming out of the tanks and then unlit flares. So in the Permian, we're using multiple kinds of measurements at different scales, from measuring the total emissions in the Permian Basin to measuring emissions at individual sites.
The environmental organization EDF is thus taking over a task that should be the government's responsibility. For more than 2 years, researchers have systematically recorded data in Texas and New Mexico. Large areas were searched by airplane. Scientists from the University of Wyoming took on the measurement of individual extraction sites and central gas processing plants. And the helicopter also continually traced down methane for the EDF. The flares are the cause of major methane emissions. They burn excess gas from oil extraction, which is often cheaper than building new pipelines to bring it to use. The researchers frequently found flares that had failed completely and were releasing the dangerous greenhouse gas into the atmosphere in large amounts. The proof that the EDF and its partners have gathered is sobering and extremely unpleasant for the industry.
And what do you think is the cost?
In the southwestern USA, apparently 10 to 15 times more methane is released than the companies declare.
So we're seeing all these surveyed sites.
The EDF continually publishes the results on a website, while at the same time informing individual operators. Their reactions vary.
Many of the operators now are trying to figure out what is exactly causing these emissions and then figuring out how they can stop the recurrence. But there still are a lot of companies who are not using measurements and really need to start figuring out where their emissions are coming from so they can start reducing their emissions.
We asked Daniel Zimmerli at Colorado State University about his view on the findings.
What about the fat tail? What about those heavy emissions? What can be done about those?
Well, so for the large emitters, you got two things. One of them is recognition that they even exist, okay? So the aircraft overflights you're seeing in many basins, even satellite work you're seeing now, is highlighting that they exist. 5 years ago, people just, they didn't believe they existed, okay? So awareness is job one, okay?
We talked to Dan Zimmerle of CSU at METAC, and he told me that the operators are very often surprised how much stuff there is, especially when it comes to the heavy tail, to the super emitter stuff. That sounds like your member companies might not know a lot of their emissions.
I would disagree with you on that, actually. I really would. And I can't speak for Dan, and I can't speak for the work that he's doing. All I can speak to really is knowing the internals and the way that our member companies operate.
Apparently, many companies in the oil and gas industry are still in denial. But they are under pressure from a continuous stream of new revelations. At Kairos, the French data analysis company, the specialists have continued to refine their methods. They can now even filter out individual companies and facilities from the raw data that the environmental satellites provide on a daily basis. They show us images with yellow stripes of kilometre-long methane plumes. Several metric tons of climate-damaging methane gas per hour are blown into the atmosphere from one single facility. And the analysts track down such super emitters worldwide in practically all the large oil and gas extraction areas.
This is huge. We thought at the start of our work that we would pick up maybe a dozen such events every year. We sometimes pick up a dozen a day. We always pick up more than a dozen a week. So those events are very, very frequent. They're intermittent. They don't last for a very long time. But in a few hours, a super emitter can emit as much carbon equivalent as tens of thousands of cars for an entire year.
The analysts tell us that in early 2022, emissions even increased by an additional third in the southwestern USA. But they also find super emitters in the Middle East and in Russia. Yet, there is still resistance to these revelations in the industry.
Initially, when satellites started revealing levels of emissions that were significantly above what the companies were reporting, there was a little bit of disbelief, discomfort, and pushback. We're now beyond that point. We're now at the stage of coming up to terms with a stark reality, which is a problem, a challenge, because it casts a negative light on industry. But it's also an opportunity because so much can be done quickly, can be done cheaply, and can be done in a way that can be communicated in a way that can be trusted.
Technical solutions already exist, as can be seen at Colorado State University. Here, Daniel Zimmerle and his colleagues show us measuring devices that can trace methane emissions quickly and cheaply. Many different manufacturers are currently having their sensors and cameras tested on the grounds. The goal is to monitor extraction facilities and pipelines continuously and comprehensively, and around the clock, in contrast to standard practice. The researchers run a secret test protocol so that the test is as realistic as possible.
Is that one not trending at all?
Over several days, they repeatedly release differing amounts of methane gas in various places.
See where they don't measure zero very well, right?
That's the normal lower range.
That's sort of just the floating bottom end, right?
Right.
The operators of the measuring instruments don't know when, where, or how much. The measuring systems must immediately warn the operator of an extraction site so that the methane leak can be sealed. It works. A methane camera kicks in. Problem solved.
I'm in the business of leak detection and repair, so I should be the grand champion of leak detection, right? But in reality, leak detection is probably the worst way to mitigate emissions, right? Okay, it's the equivalent of looking for the horses after they already have run out of the barn, right? So what you really want to be doing is using the information from your leak detection to improving your process. So the way to mitigate emissions is to start with controls on your site, the design of your site, to make the emissions less probable. And then you come in at the end with leak detection to find out when that control didn't work.
Such continuous measuring methods are not yet widely used, not even in Germany. Up to now, the oil and gas companies have stuck to searching for small leaky spots once a year. This means they too might be overlooking methane emissions on an unprecedented scale.
There is a gap between what is reported and what is actually measured. And we're interested in filling this gap. There are emission sources that we might not have on our radar yet. Of course, we're working on this gap, which is why we have these initiatives. We understand and we want to improve.
In Berlin, a non-profit organization is observing the industry's activities very closely. Environmental Action Germany has long called for a more consistent approach to methane emissions in the oil and gas sector. We want to find out from Executive Director Sascha Müller-Kräner what he thinks of the company's efforts.
It's good that the industry now practices self-regulation. But in addition to self-regulation, we need legal regulations because ultimately measures that cost money are involved. And in doubt, if only non-binding self-regulation is in place, companies will skip costly measures to reduce methane. This is why we need clear legal regulations.
The organization is critical of the fact that companies in Germany have not even been obliged to measure their methane emissions up to now. Though the EU is working on a common methane strategy, people have been wrestling with it behind the scenes for nearly 2 years. The draft resolution requires companies to measure their emissions and also stipulates that natural gas can no longer be intentionally released. This is still practiced in many countries during maintenance work. Things can be done differently. Long-distance network operator OGE is building a new compressor station on an active gas pipeline in northwest Germany. It is full of natural gas, and the places where the pipeline can be sealed off are 17 kilometers apart. In order to safely open the pipeline, the natural gas, more than 500 metric tons of it, must be removed from this section.
With this 17-kilometer section of pipeline that is now disconnected and being cleared of natural gas, you could supply 530 single-family homes with gas for a year. 10 or 15 years ago, you would have just released the gas into the atmosphere.
Where this is still in practice, in Russia for example, a super emitter shows up in the methane satellite images. By investing in such trucks, OGE has drastically reduced gas venting in its own operations. These are mobile compressors that use high pressure to transfer the natural gas between the sections. The gas is no longer lost. Even before the war in Ukraine, it would have been worth more than 130,000 euros. Today, it's worth many times that. One more reason to stop releasing natural gas.
The EU's methane initiative contains a number of useful things. For the first time, methane emissions are to be recorded and reported in a uniform way, though many important elements are still missing. Most importantly, most of the natural gas is not extracted in the EU, but imported, and the majority of methane emissions do not take place within the EU, but in the producing countries.
The European Union can only cover a small portion of its natural gas needs with its own extraction. Major suppliers are Norway and, up to 2022, Russia. Before the war in Ukraine, around 40% of the gas needed originated there. The EU imports much smaller amounts from Algeria, Qatar, Nigeria and the USA. Due to the war, the Russian share is quickly shrinking, and more is to come from the USA and Qatar. But Germany and the EU have almost no influence on the methane emissions in any of the places from which they will import gas in the future. And the supply crisis brought on by the war in Ukraine puts the importing countries in an even weaker position. Though it doesn't seem enforceable at the moment, in view of the climate crisis, high standards for clean extraction are a must.
The EU should introduce a label for natural gas that is imported into the EU. We need to look at, is it really transparent? How much methane is released during extraction? And what about its climate impact? With all the things we must now do for energy security, we must not lose sight of our climate goals. Sometimes I feel that we're not thinking enough about the climate at the moment.
I think there was some kind of emerging competition between the US and Russia on methane to compete for the European market, because Europe was getting serious about the border mechanism, price, and tightening the regulations around methane. Now, with Russia out of the picture, potentially out of the picture, that puts less pressure on the US to compete on methane. Now, all this, I'm afraid, is a casualty of one of the many casualties of the conflict.
The sobering conclusion of our research? More than 80 million metric tons of methane continue to escape into the atmosphere as natural gas, year after year. And this could be prevented. For now, the gas is heating the atmosphere further and further. But it's also urgently needed as a valuable energy resource. Scientist Ralf Sussman continues to measure methane on the Zugspitze every day. The concentration has now reached new, record levels.
You really feel powerless once you realize all the industry and transport sectors require a massive transformation. Of course, no individual can manage it. It requires political initiative. And you see that global politicians' hands are somewhat tied. We can only hope that at some point progress will be made, significant progress. We don't have much time left.